So our next topic, and linking to volume, is going to be density. Okay, density. Density relates the weight of something to its volume. So remember at the beginning last week we talked about speed, distance and time. Well, density is the same kind of thing. It's related to two other things. Density relates the weight of something to its volume. So there we've got density, weight and volume. This is where volume comes into play. Density is how thick something is or how solid something is. So on this particular picture here we've got that's a sponge, or it could be cork, and you can see it's not very thick, so it floats about on water. It's not very dense, it floats about on water. Then we've got wood, which is slightly denser, slightly more thick, slightly more solid, so that half sinks, half floats. But there's metal, dense, solid, boom, drops straight to the bottom of the water. Okay. Like speed was miles per hour or kilometres per hour, when we're talking about density, we're talking about the weight of something compared to its volume. We've just learnt that volume is measured in centimetres cubed or metres cubed. Okay, we've just learnt that. Weight is grams. Okay, so if we were talking about the weight of something, it would just be the gram. If we were talking about the volume of something, it would just be the cubic centimetres or cubic metres, depending on what we're talking about. Okay. So it's kind of like speed, distance and time. So there's the three formulas you need to remember. You don't need to write these down because we're going to do the triangle in a second. But what I want you to make you aware of, that in some of the questions, weight is often referred to as mass. Okay? So if you see a question that says what is the mass, it basically means what is the weight of something. Okay? Then we work these out exactly like we did the speed, distance and time by using this triangle. And we use it in the same way. If we're looking for the density of something, we cover it up and it's the mass or the weight divided by the volume. If we're looking for the weight of something or the mass of something, it's the density multiplied by the volume. Now, in a lot of instances, you'll be given the density, or you'll be given the mass. 9 times out of 10, you'll have to work out the volume. Okay, this is why it links to what we've just learned. This is why we have to learn how to do it. So I'll give you a couple of examples, and then we'll do a couple of questions. So these are a couple of examples. We've got this one here, we've got that one there. This piece of wood is 8 centimetres by 4 centimetres by 2 centimetres. So as soon as we read that, we can see those three figures mean volume. Length times width times height. Because we know we need volume. Has a density of 0.8 grams per cubic centimetre. What is its weight, or what is its mass? So using our little triangle, we cover weight up and it says it's density multiplied by the volume. We've been given the density, it's 0.8. So we have to work out the volume. This is why we've learned to do this. 8 times 4 times 2. 8 times 4 times 2. So the weight of that piece of wood, or the mass of that piece of wood, is the density multiplied by that. There's the density, 0.8. That's 64, the answer to that's 64. 0.8 times 64, so the weight or the mass of that particular block is 51.2 grams. Does that make sense? In that question, you've been given the density, you've not been given the volume, but you've been given the measurements to work out the volume. Because you need the density times the volume. The question said, what is its weight? This makes sense, yeah? On this side, we've got this little conversion at the top here. It's nothing to be frightened of because 1 millilitre is equal to 1 cubic centimetre, 1 for 1. This jug contains 35 millilitres of water and it weighs 24.89 grams. We've been given the weight. What's the density of this water? So we need the formula to find the density of that water. We need the weight of it divided by the volume of it. Now volume is measured in cubic centimetres, remember. You've been given the weight, 24.89. There it is. It's divided by its volume. Well, the volume, remember, is cubic centimetres. We've been given millilitres. But it's quite easy, isn't it? 1 millilitre is 1 cubic centimetre. So 35 millilitres is going to be 35 cubic centimetres. There it is. 24.89 divided by 35 gives you a density of 0.71 grams weight per cubic centimetre volume. Yeah? Does that make sense then? All the information you need is in the question. It's like the speed, distance, time one. It's all in there. It's all virtually all in there. 9 times out of 10 you would have to just find out the volume because that's using that formula that we know. Okay? Let's try one. Here it is. A 0.57 kilogram bottle of tomato ketchup has a volume of 495 cubic centimetres. Calculate the density, the thickness of the ketchup in grams per cubic centimetre to 2 decimal places. So when we see that question, what we've got to remember from last week, how many grams are in a kilogram? Because we've got 2 different units of measurement there. It's asking you for it in grams, but it's told you that the weight of that bottle is 0.57 kilograms. So what does that bottle weigh in grams? How many grams in a kilogram?
1,000.
1,000, yeah. So what are you going to do with that number?
Times it by 1,000.
Times it by 1,000, yeah. Times it by 1,000. So that's the first thing you need to do. Once you've done that, you've got the numbers. Get your triangle up. Cover up what you're looking for, which is density. Mass divided by. Let's see if we can work that particular question out. So that's the first thing we did, and we changed that to grams, yeah? Change that to grams. Firstly, convert 0.57 to grams. So that's 0.57 times 1,000, 570 grams. Yeah, 570 grams. What's the formula then? What's the formula to working out the density? It's the mass times the volume, or divided by the volume? Divided, yeah. Mass divided by volume. 570 divided by 495, it's in the question, equals 1.15 grams per cubic centimetres. That's the density of that source. Yeah. So far so good. What about this one then? This cube has a side length of 6 centimetres and has a density of 12.5 grams for every cubic centimetre. Calculate the mass of the cube in kilograms. Okay? The weight of that cube in kilograms. Mass means weight, remember. Okay? And again, look at what we've got. Look at what we've got in our measurements. They're not terribly difficult questions, so they do try to make them more tricky by putting grams and kilograms in the question. Got an answer. We've got an answer already there, yeah. Is that right for the triangle? M goes at the top, yeah. So we're looking for the mass of this cube. Density times volume, is that right? Yeah? $12.5. What's the volume? 6 times 6 times 6, isn't it? Yeah. So work out the volume of the cube first. 6 times 6 times 6, that's 216. Mass is equal to the density times by the volume. 12.5 times 216, which is 2,700. We're in grams because we've used grams there, remember. Divide it by 1,000 to go from grams to kilograms, so that block weighs 2.7 kilograms. Yeah? They're not amazingly difficult questions, these. But what is tricky, and this is what makes them tricky, is the fact that they'll give you this, 2 different units of measurements. They might only give you one number, 6, but you know that it's a cube, so you know that a cube is the same length times width times height. They're all exactly the same size, which in this case is 6. 6 times 6 times 6, 216. Remember that formula, and remember how to use it. If you work in the mass, you cover it up, it's density multiplied by volume, or whichever one you're looking for. If it be volume, it'd be mass divided by density. 9 times out of 10, the information you need is in that question. Yeah, it's in the question. Once we've worked out the weight of this cube, it was 2,700 grams. We've not done any converting at that moment in time. We'd used that 12.5 grams number there. So then once we got the answer, we divided it by 1,000 to give us it in kilograms. Okay? So far so good. Let's look at this question. This is taken from an exam paper. Okay? Taken from an exam paper. It's in your booklet, in your little workbook. And I've called it a scaffolding question because we're going to break it down. It's there. Okay? It says 1 at the bottom, page 1, but it's not actually page 1.
Like halfway through.
Right, so we're going to break this question down. We're going to do it. We're going to do it as a team. I'm just going to redraw the picture. You got it?
I can't find it. I'm going to do that. I've got the wrong paper. I've got the wrong paper. Yeah. Oh, there you are. So, it's near. Shiny, yeah, that's good. So that's really good. That's it.
So I've drawn the same picture as you. Okay? I've drawn the same picture as you. We've got a little box at the top that says density is equal to mass divided by volume. And we've got some information. So let's look at the information first before we set off. Nicola wants to put a flat roof on a bike store. The roof's going to be made of concrete and it's going to be in the shape of a cuboid. So straight away, a cuboid. As soon as we hear that word, We know we're going to have to work out the volume. We know we're going to need to use length times width times height. That's got to become second nature. There's our little picture. Okay, we've got a nice little picture of the flat roof. Nicola wants to put a metal strip along 2 of the longest edges of the roof. So we have a quick look at the picture and we can see that that's the longest edge, it's 3.5. So this side is also going to be 3.5. So the metal strip is going along there and along there. She knows that the density of concrete, we've got a bit of density in there, is 2,300 kilograms per cubic metre. And the mass, or the weight, remember, of 1 metre of metal strip is 5 kilograms. Work out the total mass, or the total weight, of the concrete and the strips that she wants. Okay. So, what do we need to do? Well, we need to work out a couple of sums, don't we? We need to work out the weight of the concrete, we need to work out the weight of the strips, and we need to add them together, because she's asking for the total mass of the concrete and the strips that she wants. Do we understand the picture? Yeah, we do. That's a cuboid. Alright, it's a cuboid. Not a cuboid as we know a cuboid looks like, but that's what it is. It's a rectangular shape. It's got some measurements on. We need measurements for volume, length times width times height. Can you spot anything?
Yeah, there's
got
metres and
centimetres.
centimetres.
Yes. We've got this. Centimetres. Yeah? Everything else on that information is metres. Cubic metres, metre. Metres, metres. So we need to do something with that. We're going to change it. We're going to divide it by 100 to make it into metres. So let's divide that by 100. That's then going to give us what? 0.12 metres, yeah? So far so good. So that's the first thing we need to do. We're doing okay. Made a start. So the second thing we need to think about is, what's the volume? And we need to work out the volume because, let me just put that arrow there. We need to work out the volume because we need it in this formula. Yeah, we need it in the formula. It's part of the formula. The length times the width times the height. It doesn't matter which way around we do these. It doesn't matter which is the length. It doesn't matter which is the width. We know which is the height. It's showing us that. It doesn't matter which way around we do it. Two times 3.5 times 0.12. That's the way I've written it down. You might have done it 3.5 times 2 times 0.12. That's entirely up to yourself. 2 times 3.5 times 0.12 equals 0.84 cubic meters. Okay? Cubic meters. That's the volume of that. Okay? That's the volume. Now we've got the volume. The question has given us the density. We need the mass. What is the total mass? The weight. Yeah? So we think of our little triangle. Ignore that formula up there because it's confusing you. We need the mass. Density multiplied by volume, yeah? Cover the M up on our little triangle. We've got density times volume. There's the density, 2,300. We just worked out the volume, it's 0.84. That's going to give us the mass. Yeah? That is going to give us the mass. It's equal to the density times by the volume. Okay? So we've got our 2,300, which is the density. We're going to multiply it by 0.84. 1,932 kilograms, because we're in weight, remember? Mass is weight, we're in weight. Weight's kilograms. kg. Why is it kilograms? Because we've got kilograms here. Okay? Kilograms. We've nearly finished, because what we've done there, we've found out the weight of the concrete roof. Okay? Just the concrete roof. The next part of the question says that Nicola, she wants to put a metal strip alongside two of the longest edges of the roof. So that's this edge here and the corresponding edge, which will be there. Okay? Metal strips are going along that side. And the question says to us that the mass or the weight of 1 metre is equal to 5 kgs. Okay, now it's not mentioned volume, it's not mentioned the height, it's just saying 1 metre of it, okay, is 5 kilograms. How many metres of metal strip does she actually need? Well, she needs 3.5 for that side, and she needs 3.5 for that side. Can you see where those two numbers have come from? So in total, she needs 7 metres of metal strip. Okay? 3.5 for this side, 3.5 for that side. In total, 7 metres. If 1 metre weighs 5 kilogram, 7 metres must weigh 35 kilogram. 1,932 kilograms for the concrete, 35 kilograms for the metal, 1,932 plus 35, 1,967 kilograms for the total weight of the roof, or the total mass of the roof, 1,967 kilograms. That's a typical style of question that involves volume. There's only that one bit. Again, like the swimming pool, worked out one volume question. Like the fish, one volume question. That's the only bit. The rest of this one involved a little bit of density. And then it involved this little extra tiny little bit down at the bottom for these two metal strips. So standalone volume questions are pretty rare. They'll be part of another bigger question, yeah? Another bigger question. And a lot of the time they're going to be linked to mass and density. Okay? So you need to remember that little triangle. It's like the speed, distance and time triangle. Okay? That's what you've got to learn to remember. I don't think we've got the answer on there, but that's the answer that we've just worked out. Anyway. Okay? So we're going to try another one of these. I've not got it on the screen. I'll draw it on there in a second.